Last week's big nor'easter was a forecasting success in eastern New England, where 1 to 3 feet of snow fell. But for Philadelphia and especially New York City, where 2 to 3 feet was predicted, the forecast was a bust. In those places, there was considerable uncertainty about the snow, but that uncertainty was not communicated well. About 10 years ago, the National Academy of Sciences published a report completing the forecast, which concluded that no forecast is complete without a description of its uncertainty. Yet the truth is, most weather forecasts convey little, if any, uncertainty, in part because it takes time to do it right. It can make forecasters look like wafflers, and frankly, most people just want the forecast short and sweet. Of course, on Weather World, we try to convey uncertainty. The spaghetti plots from 12-day trends are a good example, but we have lots of other forecasting products that characterize uncertainty, even for short-range forecasts. And today I'll show you a few, using as an example forecasts of the storm that ended this past Monday. All these products come from ensembles. That is, we run the computer models multiple times with slightly different initial conditions to generate multiple forecasts. Now here's a graphical look at 21 of those forecasts from our short-range model last Saturday. This is for snow accumulation in State College on Sunday and Monday. And yes, there are 21 lines there. And where they slope upward, the model was forecasting snow. So in this set of model runs, the least snow was well under an inch, the most was 15 inches, and the average, the thick black line, was around 4. The spread was huge, mainly because these 21 solutions each had a different track for the storm. And there's also a product to look at that. The groups of colored shapes at each time indicate the variety of predicted locations. The storm ended up taking a more northern track than what was shown here, and that let warmer air into Pennsylvania, which ended up keeping snow totals down. Finally, here's another way to look at uncertainty. This shows the probability of getting at least 1 inch of snow based on an ensemble of 57 computer runs, including some from the European model. Now here, the maroon means that more than 95% of those solutions predicted an inch of snow or more, while anywhere in blue is above 40%. By the way, Pennsylvania's right in here in case you can't see it. You can control the threshold too. Here's the same chart, but with 4 inches of snow. And much of northern Pennsylvania was still above that 95% level for exceeding that amount, and that was a pretty good forecast. And finally, here's what it looked like for 8 inches. And trust me, when it comes to characterizing uncertainty, this is just a small subset of the products that are available. The bottom line is, it's our job to combine guidance like this with our local knowledge and experience to put together a forecast that has enough specifics to be useful to you while also conveying where the uncertainty lies. And Fred will give that yet another try in the extended forecast next.